Hello students, let's take a look at this inequality word problem. Okay, and let's start off by reading the question. On her birthday, Jenny was given $56 to spend. The cost of a coin purse is X dollars, and the cost of a notebook is $7 less than the cost of the coin purse. So right now in your mind, you'll be thinking, what does it mean by $7 less, right? So we can actually start writing an equation, an expression for this notebook would be X minus 7, right? So since the cost of the coin purse is X dollars and the notebook is $7 cheaper, so that will be X minus $7, right? Now then the story continues with a pair of shoes cost $12 more than a coin purse. So shoes would cost X plus 12, right? Because it's $12 more. Okay, so we've got one more item, which is, of course, our coin purse. Our coin purse is X dollars. Okay, so you've got X dollars for coin purse, you've got X minus 7 for notebook, and you've got X plus 12 for the shoes. So again, looking back at the question, Jenny was given $56. Can she spend more than $56? Very unlikely because she only has $56. So what would it be in your mind for the inequality? Would it be the sum of all the items more than 56, less than 56, more than or equals to 56, or less than and equals to 56? So the idea here is this. You've got $56 to spend. You definitely cannot spend more than that, right? So this one is out. This 2 is out already. Anything more than cannot be true. Can you spend less than 56? Absolutely. Can you spend 56? Okay, so yes, you can spend 56. You can also spend less than 56. So therefore, this is the right option. Okay, so that is how it should be in your thought process, in which when you form the inequality in terms of X. So let's sum all the items together. So you've got coin purse, you've got notebook, you've got shoes, and it cannot be more than 56. It can be 56, but it cannot be more than 56. So it has to be less than and equals. Okay, so forming it is basically the first part of the question. Moving on, with the use of the word hence, there's an implication. The word hence would suggest you need to use your answers before that, which means you have to use your answers from part A. So we're going to use the answers from part A, and I'm just going to bring it down. We're supposed to solve it right now. So combining of like terms, remember in set 1, we learned how to combine all the like terms, which is your x, x, x. So the total will be 3x. Okay, be extremely careful with the constants, -7 plus 12. Okay, do not write as -19 is not correct. Okay, this is absolutely wrong. Okay, so this is wrong. Because some students will be thinking, oh, we should use 7 plus 12. No, that's not the case. Okay, so I owe somebody $7. So you can take -7 as you owe somebody $7 and then you pay back, right? You use $12 to pay back, that's plus 12. So it should be plus 5. Okay, less than or equals to 56. And you can do a balancing of equations, -5 on both sides. Or if you learn by bringing over the sign change, okay, so that works out to be 51, right? And then of course you can divide the 3 away, and that gives you 17. Okay, so find the maximum number of notebooks Jenny can buy with the money she has. Okay, so what is the maximum number of notebooks? The cost of notebooks is $7 less than the cost of the purse. So in this case, what is the cost of the notebook? Let's work it out. Earlier on, we have already found that the notebook costs X minus $7, right? So cost of notebook is X minus 7. So we know that X is 17. minus 7, so that's $10. Okay, so what is the maximum number you can buy? $56. You have $56 to spend. So maximum number of notebook. $56 divided by 10, that's 5.6, right? But you can't buy a 5.6 book, so you can buy 5. But take a look at it. The inequality tells you that x is less than or equals to 17, which means the x can be, it can be 17. Okay, we are going to explore this, right? X can be equals to 17, 16, 15, all the way until 0, right? Less than or equals. And if I use 17 as the number, the cost of one notebook is $10, which logically is quite expensive, right? One notebook is $10. So what do you think? If my denominator is big, then the overall answer is not going to be very big. It's going to be small. So do you think 17 is a good number to play with? Now, can I take 15? Can I take 16? Can I take 5? What would be a good number? Actually, the best number to work with would be 8. Why would 8 be a good number? Because if you put 8 in here, it means one notebook is $1, right? 8 minus 7, I'll just put it over here. 8 minus 7 is $1, which means if you use $56 and each notebook is $1, then you can actually buy quite a lot of notebook. You can actually buy 56 notebook. Okay, so this would be a preferred answer. But of course, the argument is, how about if I let it be $8.10, right? $8.10, or maybe $7.10, right? Then it will be smaller and smaller. So if we were to set this question, it would be better that we use x as an integer. So there should be another statement saying given x is an integer. Okay, otherwise, there are many possibilities, right? That could be multiple solutions. Okay, so in this case, maximum number of notebook will be 56. So this would be a preferred answer. Okay, so this one is not, because it will not give you a maximum, right? Okay, that's all, and hope you learned something for the inequalities word problem.